Have you ever been worried or had genuine concern that your pride and joy could be stolen and shipped to a third world country?
Such as England.
Well, in this video, I'm going to show you how to set up your own tracking server and configure and install a device like this one on your own motor vehicle.
Hello and welcome. As mentioned, in this video, I'm going to show you how to set up your own GPS tracking system, just to keep an eye on your own vehicles and assets. Now, there are companies out there that provide tracking solutions for your vehicle, and some providers even have devices that have both GPS and local RF technologies. The local RF component can increase the location accuracy of a device below the 5 to 10 meters provided by GPS alone. Although this is great, it's not something that you can manage independently. You'll require to maintain a subscription with the service provider, which can average around £120 a year, not including the purchase of the tracking device and installation to your vehicle. So in this video, we'll be covering devices that primarily use GPS tracking. You will need the following in order to fully achieve this project: a server for your devices to talk back to, which in turn means an internet connection with a static public IP address, or more likely a domain name. The key part is having a public facing IP address and that your internet provider is not using something called CGNAT, which seems to be increasingly more common nowadays. With all this network speak, you will of course need access to your network router. This is required to configure some port forwarding rules through your firewall so that your tracking device can get access to your server. The tracking device itself, of course, kind of important. And lastly, a mobile SIM card for the tracker. GPS trackers typically do not require a lot of data to function, so we can opt for a more cost-effective mobile SIM plan. The best way to implement this project is to work from the back to the front. So with that in mind, the first thing we're going to start with is the server. For the application, we're going to use Traccar. Traccar is an open source and free to use platform with a wide compatibility of host solutions, whether you're running the system on Windows, Linux, or another platform. But additionally, Traccar has a large compatibility of devices it supports. This gives us a wide range of devices that we can choose from when it comes to finding a suitable solution for our asset. The server application does not require a lot of resources and can easily run on a Raspberry Pi or other similar single board computer. Personally, I run this system on a shared services computer as a virtual machine using Proxmox, but for this video I'm going to be using a Raspberry Pi 4B with 2GB of RAM. This will provide more than enough processing capability, and the RAM is enough to support around 50 devices and remain comfortably stable. So let's get to it and we'll run through the process of building this server. We are going to need this micro SD card. This is a 32 gig and should be plenty for what we need to do for this system. If you wanted to keep log files for any longer period of time, then you could increase this, but realistically 32 gig is ideal for what we need it for. So we have our micro SD card in the PC. So now I'm going to open up the Raspberry Pi imager. We'll go Raspberry Pi 4. Now the Traccar server application is headless. We don't need a desktop environment in order to run this, and it will use less resources overall. So we'll pick one that does not have a desktop. Debbie and Trixie with no desktop environment. That'll do it. We'll select our 32 gig SD card. Now you can call your device whatever host name you like. This is just so that you can identify it when you look at your network later on. If you want to put in a custom username and password, you can do that here. Now this is where you would set up if you wanted to connect to a Wi-Fi network using your Raspberry Pi. I would recommend that you hardwire your device, so I'm going to skip this part. Now it's asking to enable SSH, which is something that we will need later on because we will use this to connect to the Raspberry Pi remotely from our PC and configure the system. It has suggested here use password authentication. This will use the username and password that we created a couple of steps back. Enable Raspberry Pi Connect. This is not something that I intend on using at the moment, so I am going to skip this. This is just an overview of what we've went through, and if we're happy with everything that's there, we're just going to write the card. Yep, we understand this is going to format our micro SD card and we will lose everything that's currently on it. There we go, write is complete and we can eject this from the machine and stick it in the Raspberry Pi. I'll just get this stuck in a case just to give it a bit of protection. Okay, now we'll get this powered on and a network connection put in. Getting serious, the sleeves are coming up. Now at this point you're going to want to know what the IP address of your device is so that we can remote connect to it. There's a couple of ways to do this. One of them is by logging into your network router and finding the host name that we configured back in the Raspberry Pi imager and seeing if that's a connected device. The other thing that you could do is install a port scanner and scan for devices on your network, and it will list the device in there. I am going to go with option 1, so I am going to log into my router. So I can see there that my device is on 10.1.3.74. Yours will be different. What we need to do now is open up our PuTTY software, which is a remote networking configuration tool. Now I'm just going to make the lettering a little bit bigger so it's easier for us to see. And we want to connect to our IP address. So my example is 10.1.3.74. We're using SSH and connect. It will ask if you trust this connection. We will, because we know what it is. And now it's asking us to log in, which will be the credentials that we set up in the Raspberry Pi imager. Okay, so that's us remotely logged into the device, and now we can install the Traccar server software. What we want to do is create a directory or a folder that we can put it in and unzip from there. So we will create a folder or make a directory. Now if we change directory to that location, so next we want to download and install the software, so we'll download the zip file and then we'll extract it. So to download it, we have to get the file location. Now if we go to the Traccar download page of the website, you'll see all the different server application versions you can get. What we're looking for is the Linux ARM 64 version, and if we just hover over that link, down in this bottom left hand corner, you'll see the string that we are looking for in order to request that download. So it's actually coming from github.com and not the Traccar website itself. So we will type that into our request. That is now shown as downloaded. List what is in the folder. We can see the zip file. Next we need to unzip the file. Sudo unzip and the file name. Good. So now we no longer need the zipped version of it, so we can remove that, and there we go. At this point we can now install and run the Traccar service. Now that that looks to have completed, we will just check that the service is in fact running. Systemctl status traccar.service, but it is inactive. So what we'll do is we'll do sudo systemctl and start traccar.service. And if we just press up and check, the service is active and running. All looking very promising so far. So what we can do now is log into the web browser part of this system. Open a new browser tab and web browse to the address of the device. So we want http:// the IP address of the device, which is 10.1.3.74 in my instance, and then the default port number for Traccar is 8082, so you want to go colon again and then 8082. The first thing it's going to ask you to do is register, because we've never logged into this before and it doesn't have a user already recorded anywhere. It will ask you to create your user. Now this first user by default will be a system-wide administrator. Now once your new user is created, it's immediately going to ask you to log in again with that user. And there we go, we've successfully logged in, and the first prompt that's coming up there is to register your first device. Okay, so the system is now in a functional state. Next we need to ensure our selected tracking device can access the system. Now in this example I've already selected a couple of devices suitable to my requirements, and most importantly are on the Traccar compatible device list. The devices I've chosen are from a manufacturer called Teltonika Telematics. Teltonika are a Lithuanian-based company and have a large range of devices in different shapes and sizes, from basic GPS trackers to ones that have tilt sensors for monitoring a motorcycle going down, or even ones that can be connected to a vehicle diagnostic port or CAN bus and read fault codes, fuel consumption, engine temperature, and manage all sorts of information. For this video, I'm going to focus mainly on a simple GPS solution. The Teltonika devices I've chosen require to use ports 5027 to communicate with the server, and this is the port that we'll require to forward from our network router to point to our Traccar server. Every network router is different, and being able to show you how to do it on your own router is outside the scope of this video. Sorry. Now that our connection from the network router to the Traccar server is available, we need to get from the outside world to the face of our network router. This can be done by entering your public IP or WAN address into your tracking device, as long as your IP address is static and does not change. If you do not have a static IP address, you can register for a DDNS service and use a free dynamic hostname or purchase your own domain name. Make sure that if you do need to use a hostname, that your selected tracking device accepts a domain name instead of an IP address in the configuration when specifying the server address. I've linked a free option below where you have to log in and confirm you're using it every 30 days. It's good for getting your project up off the ground, however there are other less frustrating options than this that are available for a small fee. So now we have our incoming connection from the public network area right through to our server. Next up, we need to get a network connection from the tracking device. So we need a SIM card. In my personal experience, when I made the trip from Edinburgh to Penkridge and back again with my mate to collect his Land Rover, I took a tracking device with me and recorded the data used against the hours driven and the information the tracker transmitted. Now, there are different check-in times and frequencies that you can set within your tracking device, which we can get to later, but my calculations for a simple GPS location ping actively driving for 14 hours only used 1.3 megabits a day. The reality is you're not going to be driving that long every day, and even still the maximum expected data usage would be 40 meg a month, so that gives you a budget to work towards for a SIM card plan. I live in the UK, so typically I looked for a UK service plan. Most mainstream mobile providers have a minimum package of 1 gig and costs no less than £3.50 a month, way more than what we need. So eventually I found a service provider called RWG, who are based in Wales. Now, they had plans that were perfect for our low data consumption tracking device, with plans consisting of 100 minutes of calls, 100 texts, and a whopping 750 meg of data, all for £2 a month. However, if we don't use the SMS text functions of the tracking device and we refrain from calling our vehicle for a bit of pillow talk, we can stick to purchasing a SIM that is data only. Now, there was a plan for 100 meg a month for 12 months for a £5. That's 42 pence a month. Bro. So now we have a SIM. Next, it's time to head to the garage to configure and install our tracking device. Finally.
Okay, so in this section we're going to look at configuring a suitable tracking device for installing in our vehicle. Now the device that I'm going to use here is the Teltonika FMC230. Now I do plan on installing this in a different vehicle, but we'll use this just now just to demonstrate how to configure our tracking device. Additionally, I already have an FMM230 installed in my motorcycle, so we'll be able to swap these out just to maintain the continuity of our test environment. Now, these devices primarily run on the 4G network and have failover capability to the 2G network. The 2G network is planned to be switched off by the year 2030 in the UK, which is something worth knowing if you do consider buying the FMB 965. Now, this is the device that Teltonika advertise on their website as being targeted towards motorcyclists. If you do decide to go ahead and purchase this device, just be aware that it may only continue to operate for around the next 4 years. Firstly, what we want to do before we install the tracking device in the vehicle is configure it, get it set up, and check that it's reporting into our server. So I have our device here. We will open this up, and on the inside you will see the circuit board with a USB there for programming and configuring, and the SIM card slot sitting there. If you take the circuit board out of its case, you will see there is a battery in the back here and a little port for it to plug into. This battery means that if the device is ever disconnected from its main supply or removed, it has enough power to send a notification or an alert to say that it's being tampered with. Now I'm not too worried about connecting the battery at the moment, so what we'll do is we will slot our SIM card in. Once we've got the SIM card in, I'll put this back in the case, and then what we need to do is connect into the micro USB slot there and plug this into our computer. Now what you'll notice, and what you may already have noticed, is that the device does not power up on USB. These devices are spec'd to run between 10 and 30 volts, so the 5 volt USB is not going to be enough to power this up. So you may have noticed I have a battery sitting here on my desk. So we'll use this just to power up the device and get our initial configuration done. Now the devices come with a couple of different options of cables for connecting them into your systems. Now this one is the multi-core cable, and I have this because when I eventually install this in the vehicle that I plan to put it in, I want to use a lot more of the features that are available to me from the device. Whereas all we're really going to need for this one, which is the cable that I already have installed on the motorcycle, is the standard U-type cables which you would just slot on top of your battery. Now straight away we have a little green LED which is woken up in the top corner here, which is good, so we know that it's working. And next what we want to do is download the Teltonika configuration tool. So there are multiple versions of the tool. What we're looking for is configurator is suitable for the FMC230 and the FMM230. So we will download the configurator tool alongside our COM driver. Now as you're going through this install process, it may ask you to install a couple of extra components. So here we have the Windows desktop runtime, so we've got that as well. Okay, so we've loaded up our Teltonika configurator, and in here it will ask you if you want to create a new configuration, open a configuration file, or it's already recognised that we have our device plugged into COM port 7, which is the USB of this computer. So if we click on this device, it loads up the parameters from this device. Now it will tell you it's an FMC230, what its voltage is currently sitting on, what its battery voltage is. Well, we've not plugged that in yet. And the first thing what we're going to check, currently the firmware version is 3.29.18, and if we just check back on the website, so the firmware for our FMC230 is currently on version 4 revision 13, so we can download this latest firmware as well. Heading back to our configuration tool, we'll go to update firmware. We will look in our downloads folder, FMB version 4, EXM. Do you want to update the firmware? Yes please. Cool, so it's saying that it's got 3 minutes to do the firmware update, so time for a break, methinks. Good, success. So our device is now up to date. As you can see here, the device IMEI number is potentially what we're going to have to program into our server later on so that it can identify this particular device. Now if we load our configuration from the device, so we don't have anything configured in our device at the moment, but realistically all we're looking for is the absolute bare minimum basic to get the device working. So this brings us to the GPRS tab, which is probably the most important one. In here you have things for the APN settings. So we have auto APN is enabled. So if you have an EE SIM card, your device should automatically connect to the EE network, or likes of T-Mobile, Vodafone. The device will connect to whatever network your SIM card is configured for. And below the auto APN box we have the server settings, which is the most important part here. We would put in either our static public IP address in this domain box, or if we're using a dynamic hostname, we would put our hostname into here. And under your domain IP address, we've got the port number, and the port number is, from what we looked at on the Traccar compatible device list, was set to 5027 for Teltonika devices. So we will set this to 5027, and that's what we have port forwarded through our firewall to our Traccar server in our network. For the protocol, we'll keep this set to TCP. This means that as your tracking device sends a data packet of your GPS location, it will receive it in a sequential order. Rather than setting it to something like UDP, it could send a packet, you've driven along the road, it's missed one, it will bring in your next packet further down the road, and then when your second packet arrives, it will jump you back. So it's not really great for live viewing, although it shouldn't affect looking at it in the history. We'll keep it set to TCP anyway. So back up the top here we have second server settings. Now this is if you want to configure your device to look at 2 servers or report to 2 separate locations at the same time. And the one thing to be aware of if you do use this is that you will essentially double your data consumption. So just something to be aware of when you're looking at your mobile SIM plan. We're not going to use this, so we'll skip this as well. The next tab down here is data acquisition, and that is configuring the device on how frequently it will take a GPS location fix and also how often it will send that fix to you. The next tab down is SMS and call settings. I have opted for the data only SIM, so this is not relevant to me. However, on a couple of other vehicles that I've done, I have configured a mobile number in here, and then on the next tab down we have SMS events, and you can set when you want the device to send you a text message. So this particular device has Bluetooth features, which is great if you have the device installed in your vehicle but want to come back and maybe change some of the settings or put in some of the additional features later on. It means we don't have to remove it from the vehicle to plug it back in here at the workbench. You can connect to the device via Bluetooth and update it there. Now once we're happy with all the settings that we've configured into our device, first thing to do is save this to a file. Now saving the file to our PC device means that if we ever want to change any of the settings that are in the device or go back and add in any of the additional features, we can change the settings on the configuration file first before having to connect to our device. We will also save this configuration to our device, and parameters are saved. Good. Now I didn't want to go too deep into the settings of this device, but essentially the basics of what we've done is we've got it connected onto a network and it's pointing back towards our Traccar server. So let's have a look at what that looks like.
Okay, so coming back over to our tracking interface, we will select the little plus sign to register our device. What we need first is a name, so I will just call this HCR test, and the identifier. So we took a note of the IMEI number before, but it could be a serial number or another ID depending on what type of device it is that you're using. For Teltonika equipment, it does use the IMEI number, which is stamped on the black plastic bit at the front here. So, or from the configuration tool, we've seen the number there as well. So as long as you've got a note of it, we'll stick that into our tracking interface, and we'll just save that like that at the moment. So now what we need is for the device to talk into our server. So the best way to do that is probably just to pull the power here and then plug it back in. So the device is showing as green online and showing us on the map. The position is in the wrong place, but the device has not had an opportunity to get any signal from the GPS satellites yet. If you are, of course, working inside as well, it may take longer, it won't be as accurate. We need to get this device outside realistically to get a decent signal for it to update our location. Now that our device is online and reporting into our tracking system, let's get it installed on the bike.
Now, as you can see, I don't have a lot of places to install this on this bike. So typically, we have my FMM 230 under the seat here. The only realistic places I could put it on this bike would have been behind the ignition or under here. So it's under here. We'll get this swapped out for our new one that we've configured, and we'll take this a run. Brilliant. So we've got the device configured, tested into our server, and now installed in the bike. So I'll head in, we'll have a little costume change, and then we'll take it for a run. So I've just taken the bike out for a little tour. I've started away from home, turned the device on, done my circuit. Now heading back. We'll turn it off away from home again, and we'll look up the server and see what the historic data is that's pulled up from our tracking device reporting in. Okay, let's look at the history in the system that the device is reported in. So to view our device history, we want to click on the device on the left hand side, so MCR test down here, and we have this little replay rewind button. If we click on this, it will then say when do we want to look at it for. So we could set to look at just today, or we could look at previous week or month, or we can set a custom time and date range as well. So just for example, I'm going to set this custom time period. I had to have some fun with it. Why? What does it look like? So stored in the history of the system now is our route that we done. In the top left hand corner there is a timeline. Now this is all of the fixes that we have within this time period, and you can slide that time bar along and it will tell you where we were at that particular point. If you were to click on the map or even just one of the fixes again, it will bring up this additional information at the bottom of the page. So it tells us there the date, the time, what speed we were travelling at, and what the power of the system was. So it's shown there is 13.04 volts. That is the engine ignition is on, and that is the power that is being received by our tracking device. If our ignition was off, the tracking device would have a lower voltage, so it would be around the kind of 12 volt mark from the battery, and the device knows the difference between these high and low settings to be able to tell you whether the ignition is on or off. So on the left hand side of our screen, when we first added our device, there was a little engine symbol and it was greyed out, which means that your engine is off. If your engine is running and the ignition is on, that little engine icon will be green. So that is the history side of the system. Now, the system will also report positions to you in live time, but if you're typically the one that's going to be driving, then you may not get the opportunity to see this. Just as a little add-on and to give you another device to use, Traccar have a client application for both Android and iOS devices. This means that you can use your mobile phone as a tracking device. That's great if you're prone to maybe misplacing your device, or if you have a dependent that you want to check on, such as an elderly parent or a child, and just check that that relative is okay. Now the Traccar client application will likely run on a different port to your tracking device. So in this instance, the tracker is on 5027 and the client application is on 5055. So you will need to go back into your network router and add an additional port to your port forwarding rule to go to your Traccar server. Whilst on the subject of port forwarding and applications, Traccar also have a management application. This allows you to access practically anything that you can on the web browser, from adding devices to looking at live data or historic data. This is something that you should be more careful with though, as currently the system is only running on HTTP and not HTTPS. That means that if you connect to your server from outside of your network, your connection is unsecure and untrusted, meaning that somebody could potentially capture your user credentials and access your system. You're better setting up your own private VPN connection from your mobile device into your own network and connecting locally that way, or using HTTPS, which is currently outside the scope of this video. If you do want to use the remote application in its current state, you will additionally need to port forward port 8082 to your Traccar server, but consider yourself warned. Well, that's all for this video. Thank you very much for joining me. If you found this video useful or interesting, please give me a like down below. That would mean a lot. I may go on to implement additional features in the future, so keep an eye out for that as well. But until next time, thanks for watching, and I'll catch you later.